ways than one, as long as everything you do is mathematically correct, you'll eventually get to a simplified answer. Good.
It's not 7-4. On the other side?
Yeah. Well, it's both.
Yeah, both, so then there'd be 2 answers.
What you got straight? Hi. She is. I sure did.
Jared.
Is that okay? Okay, thank you.
Yep.
What is the one? It's all right. So do you need a plus or minus for correct?
What's
I,
theta fall in? Or does it not have theta?
No, it's not easier, but it just looks
It doesn't
nice.
have theta.
You actually could go with what you have. If you went with what you have, and you divided the sides with both sides, then you could have set plus or minus. Okay, so this one, I just said, hey, y over x is -1, and I know y over x is the same thing as tan theta, right? Now, you could certainly do like an r sine theta and r cosine theta, and you get the same thing, right? So, however you want to do it, you really should solve for theta. You get theta equals 3 pi fourths or theta equals 7 pi fourths. If you graph the graph theta is 3 pi fourths, that means the r is irrelevant, the angle is just always 3 pi fourths, right? So when you graph theta is 3 pi fourths, it's easy to think it's just this part, right? 3 pi fourths, and then 7 pi fourths would be this. But actually, 3 pi fourths covers the whole thing. Why does 3 pi fourths include this part?
R is negative.
Because r can be negative, right? So 3 pi fourths is enough to be equivalent to the equation y equals -x. But if you had 7 pi fourths, it'd be the same too, right?
So both answers are correct, or just 3 pi 4?
They're both correct. But it's nice to keep it simple. All right. So next one, x equals 7. So hopefully, what did you do to get rid of the x? Replace it with
R cosine.
r cosine theta, right? So you get r cosine theta is 7. Polar graphs equations are traditionally solved for r, just like rectangular equations are traditionally solved for y, right? So we really should solve these for r, especially if you're going to have to graph. You're going to want it solved for r. So just divide by cosine, and so you get r is 7 secant theta. 7 secant theta graphed on a polar plane would be what shape? What kind of a line?
Vertical.
A vertical line, right? Yes, yes. So 7 secant theta is actually a vertical line through 7. Is that not crazy?
Wait, how does he get?
Whoa.
A secant isn't straight, but a secant on the polar plane like that, with this as its radius, is. If you don't confuse polar with rectangular. Okay.
Thank you.
All right, y equals -3. So you place the y with an r sine theta, right? And you end up with r sine theta is -3 or r is -3 cosecant, which of course would be a horizontal line. Okay, a few more and then we get to do some fun stuff. So convert the equation from polar to rectangular. So the first one, if r is 12, I personally do not like replacing r with plus or minus the square root of x squared plus y squared, so I square both sides. And that way I can just replace r squared with x squared plus y squared, and I don't have any funky roots. That is my thing. It doesn't have to be yours, right? So if you replace it with plus or minus square root of x squared plus y squared, that is, it's fine, right? You are certainly within your rights. So anyway, so I would replace it and get r squared is 144, and then x squared plus y squared is 144. This I would not solve for y, because it looks so nice. What is this equation?
A circle.
It's a circle, right? You just look at it and see it's a circle.
Are circles just like really round ellipses?
They're really round
Yes,
rectangles.
they are really round ellipses, yes.
Round rectangles.
Yes.
They're also circular squares.
Okay, yes. Ah,
Circular everything.
they are.
Oh,
Because
really?
they are circular.
Oh,
Okay.
wait.
So, when I did this one, you guys already saw it, I personally took the tangent of both sides, because I know that tan theta is y over x. But you could replace theta with arctan y over x, and then take the tan of both sides to get rid of it, right? So, anyway, but I would take the tangent of both sides first. Alright, so I want you to finish this and all the rest of those off.
Yeah. How'd you guys do with this one? Did you get y equals x? Yeah? Questions? Okay. Alright. R sine theta is 3. Hey, what is r sine theta the same as?
Why?
It's y, right? Oh gosh, it's just y equals 3. That's
That one
cool.
was so tricky.
Okay. So looking at this one, the first thing I would do, whether it was an r theta or an xy, right off the bat, what did you guys do?
Multiply by 1 plus sine theta.
That's what I would do. I multiply through by 1 plus sine theta, or yeah, 1 plus sine theta first, right? Okay. So now I know r sine theta is the same thing as y, right? So I can replace that with a y. I don't like to replace r with roots, so I like to square it. I was about to square both sides, and then first period said, no, solve for r. So I solved for r first, and then squared both sides. So it doesn't matter though. So I squared both sides, and now I can replace my r squared with an x squared plus y squared, and then you just subtract the y squared from both sides, and there you go, right? You can solve for y. What kind of equation is this? What kind of a graph is this?
Parabola sideways.
Is it sideways or vertical?
Side, no, yeah. Vertical. It's vertical. No, it's sideways. Sideways. Vertical is y.
Vertical. It's vertical.
No, this
It's
is
a
vertical,
normal
isn't it?
graph.
Right, it's vertical.
I thought this was vertical.
Which one's squared though?
Yeah, Brian.
It's just a
I don't
normal
know
y
what's
equals x
going on.
squared. So it's vertical.
Hey, Brian, we have a y and an x squared.
Yeah, it looks like
What is y equals x?
What does y equals x squared look like?
Y equals, oh,
There you go.
is
Yes.
that vertical or horizontal?
This is vertical.
Yeah, so therefore this should be horizontal, right?
This is vertical.
You're getting stuck on the fact that we have the same equal to
It's
x.
y.
Yeah, but think of the y being on the other side.
1 minus x squared
You
over
can
2.
solve it for y.
Yeah.
Brian,
I'm just gonna stop.
And it would be a negative, right? So it'd be opening down?
This doesn't have the same effect as
Alright. Okay, we are going to first graph by hand. Mr. Thomas specifically said to me to warn you that you are going to have to graph parametric and polar equations by hand on your test. Okay?
Wow.
Yes. Okay. So, we're going to graph a cardioid by hand. When you have to graph by hand, here's the thing. It's tempting when you have to plug in values for theta, right? You're not given values for theta, so you have to plug them in yourself. It's tempting to just want to plug in like 0, pi halves, pi, and see what you get, right? But when you just plug in 0, pi halves, and pi, you're not going to get enough graph to have an accurate curve. You have to plug in all the known values, the common values, from 0 to 2 pi. Now, sometimes you can just go 0 to pi and use symmetry, which is what we're going to do today. So, you guys get to take the next few minutes and plug all the values for theta in from 0 to pi
I vote we boycott.
and solve for r,
I don't want. We should.
right?
Why are we doing this?
Yeah.
Each do one.
JJ, I know you're mad, but
I thought Ryan
that's not fair.
Ryan does all of them.
All the work goes together.
Yeah.
Kids work, please.
Yeah.
I think you guys should practice this because there is going to be a lot of trig and you're not going to be able to make Ryan do them all when you take your test, right?
That's what you think, Miss Fred.
Jesus Christ, just remember, we're all sitting.
Yeah.
And I know how to do science.
Miss Price, this is when the unit circle painted on your wall would come in handy a lot.
Oh.
Can we take tests of Mr. Thompson?
No.
Miss Thomas is a calc teacher.
You will not have
That's why they
unit
get
circle
better
on AP exam. You don't get it now.
But this is the AP exam.
Exactly.
Yeah.
Apples to oranges.
Yeah.
Grapes to fruit.
Stop, Will.
Grapes
No.
That was bad.
Well, you know, I think a much better analogy would be tomatoes to fruit. So tomatoes are vegetables.
Oh wait.
Vegetables, yeah. You know what else is a vegetable? Pizza. Yeah. Pizza's a vegetable. There's tomato sauce.
Yeah.
If you're wondering where that picture was taken, it was at Hennepin County Jail. I was getting a little too wild over spring break.
Hey, we should probably work.
in your pocket.
There's a reason why the tips aren't showing.
Jeez, Brian.
Wait, is that? Oh, this one.
He's smiling too.
They're all wonderful.
Mine's wonderfuler. Yeah, it does. Look at the view in mine.
What view?
Can we put Corbin and
Do you know which one is honestly the best? I can say which one is the best.
Bailey's cool.
The best one, and no one can argue this,
If I argue
is
with
this one right here.
no,
Do you know why?
L'Hopital.
Who are they standing in front of?
Well, hospital.
They are standing in front of a statue of L'Hopital in France.
What are you talking
Right?
about?
It's pronounced Les Hospital. Hey Cole, isn't it pronounced Les Hospital?
Knowing your 80s is pretty cool.
Yeah, this is the best. I jumped.
Alright, so anyway.
Cole, at the camera.
Okay, have you guys got your table made? This is good mental practice, you need to do this, get it done. Think through it, because the more you think through it and work through it, the faster you'll get at doing this, and you do have to do this a lot over the next few days. Take advantage of this time to practice.
You know how hard thinking is?
Or actually, rotary over two. Rotary over this.
What? Hey, Danny, what's Sam?
I say cosine.
That's because I'm stamping all the girls.
Wait, are we supposed to graph that up? On this?
What's college?
I went by twos. I did 2, 4, 6.
Personally, I'm just gonna.
2, 4, 6. We appreciate.
He makes it. I've got 2 phones.
It's zero.
It's a 0.
No one's using that exercise, right?
It's so weird.
You will not have, your test is half no calculator and half calculator.
Wait, and our test is after the AP?
Your test is after the AP exam.
So the graphing will be helpful?
Yes. I honestly don't,
I know,
but Mr. Thomas specifically said to warn you guys, so I'm assuming that you will have to graph out no calculator. With a cardioid. Is that what you meant by thinking?
Okay, I know it's really.
Oh my god, I'm already on Joe Power 3.
This is.
No, I'm not using it.
Yeah, I should-
I was like, I just checked it out. Wait, I didn't know I was.
Oh, yeah, never assume. I think I know what assuming does.
You know what happens when you listen to
what are you talking about?
Alright, I really like this graph because as you work around the unit circle, it almost kind of feels like a spiral because the radii get smaller and smaller as you move from 0 to pi, right? So, and by the way, someone was asking earlier today, how are we supposed to approximate root 2 or root 3 when we are graphing?
Root 2 is 1.4, root 3 is 1.7.
Oh, there you go, okay.
It's written on this
So-
ceiling.
Root 2 is 1.4, root 3 is 1.7. I like to think of them as around 7/5 and around 7/4. Because because I'm a fraction person, and when you're doing like 3 root 3 over 2, I can do fractions better than I can do decimals.
So why do they keep decimals then?
Decimals come in kind of handy for a lot of purposes. Yeah. Quite a lot.
I may or may not have been doing this.
Okay. Alright, so check your R values. And then, once you have it, I want you to sketch your graph.
No, when people think of you over the weekend, it takes years off your time.
Devin, are you gonna fight? Brawl.
Leave me alone. Do you have usually in your car?
No.
When you graph from 0 to pi, you only get the top half of the cardioid, but it is symmetric, so you can go ahead and plot symmetric points and get the bottom half. It's very hard to freehand these well, so you really do need to plot some points. But yeah, make sure you practice graphing.
That's what I thought.
Well, it depends on the graph. Some graphs don't have symmetry.
But the cardioids.
The cardioids do. But if you're doing like a 3-petal rose,
Coming to my
there's
bedroom.
kind of a symmetry, it's a rotational symmetry, but it's harder to.
This price, I've already been through half my notes.
Wow.
I just do a new notebook. I just use this newspaper.
Okay, any questions on how to graph by hand? Basically, you're just plugging in a ton of values for theta and getting out your R's, right? Okay, so it's time to learn how to graph on a calculator. So we're going to graph a rose. We're going to graph a 5-petaled rose on our calculator. I have some things to warn you about when you are graphing on your calculator. So please don't try to jump way too far ahead, because there's some nuances you've got to be careful about.
Joe, you getting amped up for the rifle ones?
First thing you have to do, first thing you have to do is change your mode. 5, please. So make sure when you hit mode that you are in polar. And so you have function parametric, you want to switch to polar. And please make sure you are in radians. I cannot emphasize enough, if you are accidentally in degrees on the day of the AP exam, you will probably lose about 10 points off your raw score. That's a big deal. So you really need to make sure your calculator's in radians, all right, for everything. It's all degrees, I know. All right, so we're polar, we're in radians. Everyone got that?
Yeah, except for
When
Thanks, Paul.
when we type in our equation, it has to be in terms of theta. The 84, when you type 7 cosine 5 theta, you just use the X button and it defaults to theta when you're in polar mode. If you're on an 89, the theta is actually diamond and then the little caret. It's next to pi. So if you have an 89, you have to do diamond caret to get theta.
This is fine.
All right? All right, everyone has it? Wait, don't graph.
What should our window be?
Okay, that's what you're gonna go to next.
Oh no.
Does everyone have this typed in?
Oh no.
Theta stepping.
Window. Hit window.
My theta step.
Whenever you're doing polar, you want to default 0 to 2 pi for your theta min, theta max. Sometimes it'll double up. Sometimes one complete cycle is just 0 to pi, but sometimes it's 0 to 4 pi, but 0 to 2 pi is a very good default to start with. Do you guys remember when we did parametric that the t value, when it graphs parametric and polar is the same way. When the calculator graphs parametric and polar, it's not doing it using the equation and intuitively graphing. It's literally plotting points and connecting dots. So that t value, if you remember the t value in parametric, the smaller the t was, the smoother the graph we got. If it was a really big t, we'd get these kind of disjointed lines, right? So if we do a theta step here of like 1, I'm going to do a theta step of 1 just to show you. The x min, x max, that's just your window, your viewing window, that's fine. You could do negative 10 to 10 for those. If I graph this, there's my graph with a theta step of 1, right?
It's a beauty.
Is my beautiful? Yeah. So it literally plots the points and connects the dots. So if you want a theta step, I usually default to 0.1 because then it's anything smaller is going to take a long time. So 0.1 will give you a fairly decent smooth curve, and it doesn't take long. Now, are people having problems? Need some help?
Wait, what's point 1?
Your theta step.
Oh, okay.
My
Yeah.
data stuff.
Oh, good.
My theta step is 2.
Yeah, see, there you go. So you all graph the rows. Okay.
I'm actually gonna try. It's really is nothing.
Oh, you're cosine 5 theta. The number that's, guys, the number that's in front of the theta, if it's, if I remember right, if it's odd, it tells you the number of petals. If it's even, it's twice the number, I think. Here, let's try. Yeah, let's try and see. It's been a while.
Oh, yeah.
So like if we do cosine, like I might say I make it 4.
Yeah, and it is double.
Yeah,
Yeah.
Alright, tell us one.
I don't know.
As a
It's been
teacher
so
though.
long. Okay, so anyway, yeah, so there you go, you got 8 petal rows, you do 4, 5, or 4 theta. Okay, alright, so that's it. Whoop, yes? Hang on one second, I'm gonna shut off the camera, and then we're gonna work on a quiz for the last 7 minutes. Got to get these quizzes